wanted to make this video, which is going to go through one of the elements of the unit 1.3 that we've been doing on probability and counting. This one here, I'm going to look at some of the things here in 1.3.7, which is about set language and notation for events. So we're going to look at a set, the complement of a set, union and intersection, those kind of ideas here, and just some basic ideas about sets from the syllabus. Okay, so here we've got some definitions of some of the things that you will see when you look at a textbook that talks about sets. So a set is just a collection of objects, so it can be anything really, a set of false teeth, a set of geometrical instruments, anything. We normally are talking about objects or numbers or letters or things like that. So we can define a set by a rule, even numbers less than 15. We can list the elements in the set of all prime numbers. So there's lots of different ways that you can give a set. We always use the curly brackets when we're defining a set, so that makes it different from other things. The curly brackets means we're dealing with a set. So question 1 here, example, days of the week. So this set here is populated by the words Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Months of the year starting with J. So the set B would be January, June, July, etc. Okay, so these are words that are in these sets. Number 3, I'd say set C, I would use words to define that, and I'd say that set there is letters of the alphabet from F backwards. And set D is just days of the weekend. Okay. One word that you'll see when we talk about sets is element. An element is just something that's in the set, and we use this little symbol here to say that something is an element of the set. So similarly, if something's not an element, we use that symbol there to say that it's not an element of the set. Okay, so 4 is an element of that first set there, but 5 is not an element of that second set. You don't really need to know about cardinal numbers, but if you do ever come across this, it just means the number of elements in that set. So the number of elements in set A there, 2, 4, 6, 8, 10, is 5. There's 5 elements in that set. The empty set, believe it or not, there is a set that contains nothing. We use 2 symbols for that, curly brackets or the circle with a slash through it. That is the empty set. Okay, and the other symbol that you might see is this one right here, and that means subset. Or the symbol that meaning not a subset. So subset. So things like if we have the set A, B and C, then a subset of that would be A. A is a subset of that. A and B is also a subset of that set. In fact, the set itself is a subset of itself, which I know is a little bit strange, but there you go. So we could list all the subsets of that set there. Okay, I'm going to flick down to get to the stuff that we should know. Universal set. That is when we're talking about a particular situation, everything in the set. So we might be given a question where the universal set is all the numbers from 1 up to 10. And that's everything that we're considering. And you've got this really funky symbol here, which is impossible to draw. I'm not even going to try that thing there, which we normally use to represent the universal set. Okay, complement is another one you need to know. The complement of a set is all the members of the universal set that are not in the set being considered. Okay, so if the universal set is 1 to 5, and we've got R as 1, 2, and 3, then the complement of R is 4 and 5. It's everything outside of R. If the universal set is 1 to 10 and A is 3, 6 and 9, then the complement of that is 1, 2, 4, 5, 7, 8 and 10. It's just everything outside of that set. Okay, cool. That's the complement. And we use this notation here, the A with a little dash, to represent the complement. Okay, moving on. Venn diagrams are a lot of the way that we use to represent sets, to look at them. It's much more graphical and visual, which is really good. A lot of people find this useful. So here we've got a set A, we've got the universal set sitting on the outside. We've got a rectangle to represent the universal set, and then we have subsets. We normally use circles or oval kind of things inside there. We don't have to use these shapes, it's just what we do. So we've got the set A here. I could say that everything outside of A is A dash, and that everything inside there is A. So there's you've got the set and you've got the complement. Okay, so If we've got that example from before, if we've got 1, 2, 3, 4, 5, 6, 7 is A if it's a set of 3, 4 and 5. So in this situation here, the universal set is 1, 2, 3, 4, 5, 6, 7. A is the set 3, 4, 5. And the complement of A, 1, 2, 6, 7. Cool. So you get a diagram and it makes that a lot easier to kind of see. All right, this is the important stuff now. The intersection and the union, I want to talk about those. The intersection is what elements are common to two sets. What is in both sets? So let's look at this example here. We've got a set A and a set B. A intersection B, and we use this upside down U to represent intersection. What is common to both sets? So if we look in both, we've got a 2 in both sets. We've got a 4 in both sets. There's no 5. There's a 6 in both sets. There's no 7. And there's 8 in both sets. Okay, that is A intersection B. 2, 4, 6 and 8. They're the elements that are in both sets. The word that I'd use for intersection is the word and. What's in A and in B? Diagrammatically, if this is the set A and this is the set B, the intersection is that part there. That's what we would shade. That represents A intersection B. Okay, the union on the other hand is what is in A or B. So I'll start off with straight away, the word that I'm using here when I think of union is or. So A union B, it's helpful that we've got a U going on there. Means, okay, so let's look at what's in A or B. Is 1 in A or B? Sure it is, it's in A. Is 2, is 3, yes. Is 4, is 5, is 6, yep, they're all in A, so they're in A or B. Can we also include 8 and 10? Yes, because they are in B. We don't write the elements twice, so you can see 2 is in both sets. We don't write it but twice when we're doing the union. Just write everything in both sets. Okay, so that is union, A or B. Is 10 in A or B? Yes, it's in B, so it's in the union. On a Venn diagram, this is A union B. That's what I would show. A union B. This is the set A. This is the set B. So if you think of any kind of element in here, is that in A or B? Yes, it's in B. Is something in this part here in A or B? Yes, it's in A. What about something in here? Is it in A or B? Well, it's in both, so it's definitely included. Okay. Now, some questions might ask you to shade Venn diagrams. So these ones quickly here to finish off with, I'm going to do some quick shading. So this one here wants us to shade the complement of A, so that is everything outside of A. Part B is A union B, which we know is that. A intersection B is that there. Now we're getting into slightly trickier. A union B complement. That means, think of everything that's in A or B, which I know that we just did was that, and it's everything outside of that. So A union B complement would look like this. It's everything outside of A or B. That's A union B complement. A intersection B complement. All right, so let's think here. In this case, it's got to be A and, remember this symbol here, the intersection symbol, think and, A and it's outside of B. So what's inside of A and outside of B is this section right here. In A and outside B. Right, F. Union means that it's got to be outside of A or outside B. So the way that I shade union ones is I just shade everything outside of A, which is all of this. That's everything outside of A. And then I shade everything that's outside of B. So if I change colour, this is now everything outside of B. So everything but B. There we go. That now gives me everything that's outside of A or outside of B. Okay, so basically it's everything but the intersection part. So when you're shading unions, you just shade one, shade the other, that's it, and leave them both there. The syllabus mentions 3 sets. So in this one here, we're looking for the intersection of A, B, and C, which is that little bit there, common to all 3. A union B intersection C. Okay, so B intersection C is that bit there. That's what's common to B and C. And we want to shade that with the union of A. So again, with unions, you just shade everything in A, shade everything in B intersection C, and that is your set that they're after. Okay. Now, you can apply these sets to different problems. So, in this one here, a group of students are asked if they played hockey or netball. 6 played hockey only, 8 played netball only, and 7 played both. How many students were asked? Okay, so this is hockey, this is netball. 7 played both, so I know that you're going to have a 7 in there because that's the intersection. 6 played hockey only, so that's that bit there. So it's outside the netball circle, just in the hockey circle. And 8 played netball only, so I know I can put an 8 there. So as long as a group of students were asked if they're one or the other, then I just need to add those numbers up there. So that gives me 21 total students that were asked, assuming that there's no students that played neither. Okay, so in this one here, we've got a youth club. They're asked if they could play musical instruments. This is guitar, this is piano. We're told that 3 could play only the guitar, 4 could play only the piano, 7 could play no instrument, and 4 could play both. So how many students were asked? Add those those numbers up together. 7, 14, so we've got 18 students altogether. Last one. In a class of 24 students, we've got modern music and classical music. 16 like modern music, 14 like classical music. How many pupils like both types of music? Okay, so if we add up everybody in that circle there, we get 16. If we add up everybody in this circle here, we get 14. So when we do that, we get 30. Now, assuming that each person in the class likes one or the other, in other words, there's 0 out there, that means we've done that and we've now got 30. Note that there's only 24 students in the class. So who have we counted twice? If you look at my diagram, you can see I've counted the children that like both modern and classical music twice. So that section right there has been counted twice. So what I'm going to do is recognise now that that must be 6. The difference between the total I got here and the number of students must be that bit there. And now I can work backwards. If 16 like modern music, that means 10 must be here, giving us a total of 16 for that circle. If 14 like classical music, that means 8 must go there, giving the total of the classical music to be 14. Okay, so how many pupils like both types of music? The answer to this question here is 6. They could also ask something like, how many students liked only modern music? And the answer there would be 10. Okay, that's a quick introduction to sets, Venn diagrams, and how they're used in some practical problems like this, some notation, and Venn diagrams.